Good morning to everybody. Today we are starting the lesson number 3. In this moment, when in the meantime I'm talking, I'm also launching our software because we already see has it was being launched. Basically, it provides two important things today. The first things is having more clear detail on the management of the different views. And the second operation, which you will understand later, is very important because it's related to the color management. If you remember the operations we did last time, you see, we can from the main menu. You see, we can restore the previous layers, and you see, we can restart with the situation as we left last time. So we'll open the last version, and it returns to the previous condition. So basically, this is the fact what we can have, and of course we have only the things we have already saved, and in fact we have loaded all the files in two different windows, and you see we have also the annotation and all the things we left last time. And here is the Abo of Genoa. So we can start from here, and if we are going to the data manager, we can remind how we can load the items, and from the menu items, the data manager with the shortcut F4 from there, or from the icons we have in the bar. And you see that the data manager is, we have all the data we have available for loading. But today I want to do something different because I want to take advantage of these two windows. So we are going to the principal menu, and we are closing all the files. Closing all the files means empty the data manager. And of course, it needs my confirmation in order to do that. So you see, all the things that are containing data, the views that are containing data were empty. And I'm also deleting a view, so I have only one single view. And now I can start reopening the previous file, so we can learn again how we can do. So we are going to the main menu. You see we are open as optical sensor. You see here we are going to the Landsat, and then GeoTIFF with metadata. Remember, let's click here, and you see here I have my folder where I store the data, and you see here I'm going to the exact position. So in the folder data, so northwestern Italy, I'm going to the Landsat. For example, here you see I have. I have more folder here because in addition to Landsat 7, I have also Landsat 8. So this is the Landsat 8, and you see this more or less the same of the Landsat 7, but there are more bands. And it was mounted on the 8th version of the Landsat. So you see that also here we have a metadata file. And so we can open just this text file in order to have all the data. And you see, as always, we have a true color image that is centered in the view's particular scale. These are the characteristics that you remember for the last session, and have been defined in the preferences that we find under the preferences here. You see, so if you see here, if you are going to the data manager, you see that you have here true color, so auto display, yes, and the image is displayed in true color. So it's selecting all the different visible bands in order to synthesize a true color. So this image is different from the previous one, and if you remember correctly, I opened this window so I can see how the metadata is done. So you see, I'm just try to reduce the views in order to check all the data. So, so you see also in the name of this file of the metadata, you see the data, the acquisition file. So you see that it has been acquired the 14th of April 2020. So it's a very recent file, and will show the same area and the same scene in a but we are using the data manager in order to check all the different bands. So you see here is the data manager. So fundamentally, it's more or less the same, Landsat 8 and Landsat 7, apart from the facts that you see in the first data set, we have an additional band. So that is the first one that is called the coastal aerosol. And you see, this is the first one. So there's a shift of every single band because the former Landsat 7 bands, the blue band that is the number one, now is the second one. So the blue part of the spectrum is divided into two different spectral bands. The coastal aerosol, the first one, is the classical blue one. And the first one is just used for marine application. And you see there's a there's a there's a panchromatic bands that is the bands that was already present in Landsat 7, but with an higher geometry resolution. Then we have the thermal infrared bands here. And you see that we have two different bands with more or less the same wavelengths. There's another band in the medium infrared that is called Cyrus. It's 1.3 microns, and then you have also the last bands that is a quality bands that is related to the quality of the overall data sets. So what we can do with this data manager? So let's close these things. I'm zooming with the wheels of the mouse here in order to see all the scene. And you see that what we can see here is the full scene. And if you are going to the layer manager and we explode that, you see that we have used three different bands, the blue, the green, and the red, in order to synthesize the true color image, associating these three bands to the red, green, and blue channel of the screen. This is the synthesis that we can observe with our eyes if on board of the satellite itself. So having said that, we also try to do another things with the data manager, you see here. So we can, I can load other things, other bands. So I can on another additive synthesis. So I can use also this option here. You see in the data manager, we can in order to have more safety in when we are selecting the different bands, we can use this option, the band selection, where you see we have three different fields with the three different channel, red, green, and blue. So to the green, I can just add these particular bands. You see that now it's comparing in this tab. I'm associating to the green and blue channel the red and the green band. So this is a typical a false color. And you see, we can check what is happening at this point. So you know that now we can load in a new view, just setting this option here, and the layout will be divided, will be split in two different things. Or if I want just to overlay these things, I'm just press on load the data without the option of loading a new Windows. So you see that when I upload this image 432, you see we are here. So you see in the same view, you see here in the layer manager, we have more additive synthesis. You see here, now we have the false color, But you see here, we have also the true color image. So in the same view, we can have more additive synthesis. So if I'm getting out the visibility from here, you see, I mean, in the view, we have nothing. Otherwise, we have overlaid the different views. So what is happen? It happens that we can load in the same views multiple images. And if you have multiple images, what you can you get, and this is the first part of these labs, in all the different active windows, you see, you can you can have activated these particular icons there. You see the blend, the flicker, and then the view swipe. So you see, when I have these views are activated. I have also these particular icons activated. So you see, I just to see how is working. If we have adding a new view, so you see, you remember here, create a new view. You see here now the screen is split into two parts. These icons are not active because I don't have any data inside. You see here, but they are not active and will be reactivated when I will upload some data on that view. There's active view. So let's upload something. You see here, I can remove these views in order to be in the previous situation. So what are these icons that I mentioned? They are extremely interesting at the moment. And you see, I have a list of data in the layer manager, and this is the fourth color. So if I'm clicking here, you see what happens if I call a portal. You see, I have a very small windows created in which, in the smaller windows, I have the other views that I have in the same views. So the bigger one you see is the false color. In the inset image, in the smaller one, I have the true color. So in the same views, using these icon portals, you see, I can see different bands in the same views. So you see, I can pen the false color in correspondence of Turing, for example, you see. So I'm zooming that, and you see, I can simply move the image, pan the image, the background that is the false color image, and to see how this particular area is reflecting in the true color. Or you see here, I can also do another thing. The other thing is just, you see here, to pen the smaller windows, the inset windows, over the background in order to check how it's changing. So you see, for example, it's possible here to visualize different spectral bands in the same view. So it's a very good stuff that seems to be very easy and quite useful, very useful indeed, because it allows to see different bands with also different spectral resolution, for example, and understand exactly how to use these overlays. And you see here in the layer manager, these new windows appears. You see, you have a small letter, a small P letter, which stands for portal, that appears in brackets here. So you see, you have the inset windows, the portal, already in the layer manager. So if you are just pressing the X there, you see you are closing this portal and the portal disappears. All right. So see, if I decide through the data manager to open, for example, the image, the panchromatic image, you see here I'm loading in the same views, you see, so I have three different views right now. So this is a higher geometric resolution of the panchromatic data, you see. And sorry, I cannot um, way. Okay, now I'm moving. All right, from here I had some problem with the mouse. So I want to zoom here, and you see here, also in this case, I can press the portal, you see, and in the portal, you see, I have the second synthesis that I have in the list. This is the fourth color. And you see, I can move the inset, the portals, in order to check how it's changing the reflectivity of the data. And so I can decide I can decide which kind of image I can define, just moving as here the order of the image. So for example, if I'm closing that, you see now the order is the second is the visible. You see that now in the inset, in the portal, I will show the true color image. All right. So I mean, it's a matter of order of what I'm explaining. So the background is always the first, the top, the image in the top of the list, while the inset in the portal, I have the second one. So you see, I can also change the order by dragging the data with the mouse, and you see again the portal, and you see here I will have now the panchromatic. I can also change the dimension of the inset image of the portal. You see, in this case, you see that it's more or less the same because I'm using the true color and the panchromatic image. Of course, they have a different geometric resolution because it's something related to 30 meters, 30, and 15 meters. So let's see the other button. So this function is particularly useful in order to explore the data. So for example, if I'm using the blending here data, you see the blending is a sort of dissolve the data, dissolve the different views in a continuous way in order to 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 use the dissolution to dissolve function in order to check how it's changing the reflectivity of the data. So I'm just re-clicking that, I'm stopping that. So I'm changing the order in order to have more evident this dissolve function. So now I have the fourth color top of the list, and then I have the visible in the second position. I'm re-clicking the blend, you see here. And so you see when is blending the infrared views and the true color one. So you see that, for example, the vegetated areas appears to be red, while in the true color, I have only the green. We can change and re-have. I have also the flicker. You see here, the flicker is flickering, just blinking with the same function as before, while the last one is the swipe. And you see, the swipe is something that is, you see the image in the background, in the top, that is swiping and changing the views. So this button are a different way to represent the data and to explore the data in the initial phase of the data of the data assessment. So I can remove now the band 8, that is the panchromatic. You see here I remove that, so I have only the two previous views, the fourth color and the new one. I'm using the data manager, and from the data manager, I can load in another view the panchromatic image. So now you see here, I have in grayscale in the second view, and for example, upload the thermal infrared bands. You see here, for example, this one, again in grayscale in the same second view. So you see load grayscale here with the button, but I'm loading that in the second view. You see, this is the thermal infrared. I can close the data manager. All right. So of course, I can link the two views. You remember how we can do that. So I'm I'm selecting this one, and you see I have the cyan frame here. So this is the frame that is representing the selected views. So of course the colors of the cyan you can select in the system preferences. You see here we can link all the views, and now you see when I'm visualizing the path of Turing seen in the false color, you see here with the infrared bands. Here in the right part, you have the thermal infrared bands with a resolution of 60 meters on the ground, so it's worse than is that one. So if I'm using the panchromatic, of course, it's 15 meters. It's much better than before. So check again the visibility here, and taking into account the fact that we are active in the first frame, we can, for example, set a portal in the first view. You see here, and I can change the dimension of the inset windows just to check. And on the second frame, I can select, for example, let's check here. I can use, for example, a flicker. You see here that is flickering from the panchromatic and the thermal infrared. And you see, I have these two different views. So with the different views, I can manage independently on our windows the different synthesis that I have available, the different spectral bands that I have available. So for example, I can dynamically manage these windows. I can remove the flicker because otherwise, I mean, it's get too complicated. And, uh, and we can start right now with the management of the chromatic components at this point. So uh, uh, we are therefore thinking of closing the different options back on the portal. So you see here, I can just right click on the mouse and you see I can remove, for example, the portal with this way, or just simply click on the X on the inset windows that I have. Just right click with the mouse here. So remove the portal. All right, and you see that now the portal is not anyway in the layer manager. So let's try to manage our colors. In order to do these things, we have different possibilities. So for the first time, I want to close the second views because otherwise it's became difficult. So you see, right clicking on that and I remove the view. All right. So I have only the first view with the two images, the false color and the true color. Just to understand what happens, I can just set an example, for example. So I can use a blend, you see here, where I'm passing from one synthesis to another. So you see, if I'm going to the hilly part of Torino, you see that what is vegetated, I mean, in true color, you see, is a sort of grayish, while I'm using the false color, you see, is very reddish. And so the fact that I'm using the real color image and therefore, I'm sorry, and the false color, which is associated with a red band, that means that whatever is more reflective in the near infrared will be reddish. So this, for example, this option is allow me to understand that in the hilly part of Torino, there's vegetation because whatever is red here is for sure vegetation, and is more contrasted in comparison with the green of the true color image. So we can use this option in order to better understand the things. So that means that the colors are very fundamental in order to extract information. And you remember that the paradigm that we introduced since from the first lesson is just to extract value-added information from the data. And this information can be only we can extract this information also using colors. So in order to check, we can just stop the dynamic overlay. So we need to resynthesize the data and to represent what we have introduced in the theoretical part, especially in chapter in lecture number 7. So you see, this is in Italian. I'm sorry for the foreigners, but this is this represents in a very concise way and is very didactic the system that is related and can easily understood of the additive synthesis and subtractive synthesis. Whereas the additive synthesis, the left part of this thing, is what is used by our monitors. So I mean, in this moment, you are using that with in face of your monitor, and so using this modality, you can synthesize all the different colors in this way. So that is the same system in which is presumed to function our eyes. So these are in the right part. We have the subtractive synthesis that is used by particular system, for example, the printers that are using the subtractive synthesis. So you see that the additive synthesis is composed by three different principal colors: blue, red, and green. So in our English system, that is one that takes the initials, for example, RGB, that stands for red, green, and blue. You see, these are the principal colors, all right? Blue, red, and green. So we know that these three main principal colors, mixed each together in the same quantities, that returns a gray tone. So, when you are mixing a couple of colors, so you will have complementary colors. While if you are mixing all three, you have as results gray tones that in this case is what is called in Italian bianco, that is the white color, okay, to the maximum saturation. So this is easily understood, and memorize this diagram because it's very important for the complementary color, because I'm representing the same colors here in these things here. So, for example, when you are mixing the two principles, you will have three complementary colors. You see, and when you have these three part of the circles where there's no overlapping, you have the principal. When you have the overlapping with two colors, you have the complementary. And when you have the overlapping with all the three colors principal, you will have the white, or in general, the gray tones. So starting from the blue and green, the complementary color is what is called, you see, cyan. That is that kind of colors that is let's say a bright blue. With the red and green, the complementary color is the yellow, and red and blue, the complementary color will be the magenta. If we add the three part of the three principle, we will have the white. So this is the additive synthesis. So we see that when we are talking about subtractive synthesis, what is the subtractive synthesis? It's something very simple that can be used, can be explained using the same drawing on the left. So, because the subtractive synthesis is not other than the word subtracting from a certain color, from white, a certain color in order to get a third color. So considering that the white is nothing more than the sum of red, green, and blue, that is represented with equals quantity of red, green, and blue, if we are subtracting, for example, a principal color from the white, the results will be a complementary color. So on the other hand, if we are subtracting from the white a complementary, the results will be a principal colors. Let's have some examples. So white, RGB minus B, that is stands for blue, the results will be green plus red, but green plus red is equal to yellow. So if from white we are subtracting blue, the results will be yellow. So this is very interesting because it's helped to memorize this complementary in the way, for example, if we are subtracting from the blue from the white, the results is yellow. So yellow is the complementary color of blue. And so it's very easy to memorize it in this way, as cyan is the complementary color of red, and magenta is the complementary color of green. Let's see the case of green. From the white RGB, minus G minus green is equal to red plus blue. That you see is the magenta. So red, white, minus red, the result is blue plus green, that is cyan. So if from the white I subtract a complementary, the result is a primary. And therefore we repeat it is in the way that is easier to remember. Primary, if we think the complementary of blue and yellow, the complementary of green. But I mean, the cyan is the complementary of red, as you see here. And of course, the complementary, that is the complementary of the primary, is formed by the other two primary, the sum of the other two primary. So if the magenta is complementary or green, magenta is done by blue and red. Okay. So we clarified right now the additive synthesis and the subtractive synthesis. So I can close these things here. I can go back to the windows we used at the beginning. So if we have associated the red, that is the infrared, to the red channel, you see that all the vegetation will be red. That because, I mean, we associated to the red channel of the visualization, the infrared bands in which the vegetation is reflecting the most. So if we remember the things that we have mentioned, talking about the electromagnetic spectra, especially from the spectral component, the spectral signature, for example, we know that I mean, the vegetation is reflecting very much in the near infrared. And so, for example, when you have the phenological and active cycle, the vegetation is always reflecting very much in the near infrared. So there's a peak of reflectivity also in the green, for example, when you have an active phenological cycle, and a peak of absorption in the red bands that come from the characteristics of the vegetation. So where we have a reflectivity peak, an absolute reflectivity peak in the near infrared. So for example, in this first color, you see, when you have the near infrared, you see we have associated to the vegetation the infrared, while we are associated to the green channel, the red channel, that is the peak of absorption of the vegetation. While we are associated to the blue channel, the green, that we have a relative peak of reflection in the visible, at least, of the vegetation that is much lower in comparison with the near infrared. So that means that the vegetation appears to be red because we have used this kind of additive synthesis. So, for example, if I want you to understand how is working the colorimetry and how you can synthesize colors, you have to understand that the colors is not an intrinsic characteristic of the surface, but is the way in which I associate the different spectral bands to the different channels. So, for example, I can use the additive synthesis simply working on the association of the bands to the different channels. So let's start with managing the colors. So let's go to the data manager, and at this point starting with the vegetation in red, let's visualize the vegetation in the other two colors. So let's visualize the vegetation, for example, in blue. So use the band selection. What we are associating, I want to display the vegetation in blue. So if I have this system, red, green, and blue, which are the bands that I have to associate? So I need to associate the bands that is most reflective for the vegetation to the blue channel if I want to display the vegetation in blue. And I need to associate to the green and red channel a band that is not so reflective. So in the red, I can associate, for example, the green band. To the green channel, I can associate the red band. And to the blue channel, I can associate the near infrared. Load data, just pressing here in the new windows, you see. So we are in the situation, because let's just I'm sorry, I'm going to zoom again in these windows. All right, you see here, for example, I'm going to the Genoa, to the port of Genoa, because it's easier to understand. Okay, you see here is the Christopher Columbus runway of the airport, International Airport of Genoa, and you see whatever is red in this runway is to be intended as vegetation. So here you see here there are parts interconnected with the two different runways. I'm linking the views. You see now I'm linking that, and you see that now all the vegetation there in the between the runways of the airport is blue. So now I want to represent this vegetation in green. So if I'm going to the data manager and I'm activate the selection, the band selection, now I need to associate to the green channel the most reflective bands for the vegetation. So to the red band, I associated, for example, the red. To the green, I associated the near infrared, and to the blue, I associated, for example, the green. I load in the new views, and I'm loading the data. And you see, I'm closing the data manager. You see now, I need to redo I'm selecting the first one. I'm sorry, I need to go again back to the same exact position. Now I'm going to relink everything. So I'm going to link views. I remove the first link, and I link all the three different views. You see, with the anchor there, this is the parent views that is linked to each other. And you see that now I have there represented the vegetation in green. So you see, we solved our problem because we represent the vegetation in the three principal colors. So you see, I use the airport of Genoa because it's easier to understand these things. So these are the three principal colors. We can do another things. So if we are going to the data manager, we can reopen the band selection, and we can see, for example, if we are doing this kind of synthesis. To the red channel, I'm associating the near infrared. To the green channel, you see that is moved to the green channel. I'm associating again the near infrared, all right? So you see that now the icons is red and green, and you see the same bands is associated to two different channels. I'm associating the same bands also to the blue channel. So you see, I have associated the same bands to the three different channel of visualization, red, green, and blue. I'm loading in the new view. Let's theoretically understand what will happen. If we are associating 3 equal components of colors to the 3 principles, the results will be ever a gray tone. You see? So associating the same bands to the 3 channels, the 3 display channel in RGB means that we are doing the same things as loading a grayscale. Because I mean, the results will be the same image. So let's load this data. And you see, we are closing the data manager. Do you see? We have 4 different windows. I'm selecting this one. All right, I'm going to the link views. I remove the first link. I link that the 4 different windows again, and you see that associating the same band to the 3 different channels returns a gray tone image, of course, because the same quantity of reflective intensity in the same cells returns, of course, in the 3 principle returns a gray tones. So now let's do something more complicated. So in order to understand how the complementary colors are working. So let's use and have fixed the panchromatic. And we are using this first views with the cyan frame. And in this cyan frame, in this first view, instead of using the red, we are using the complementary of red. You see, so we need to represent the vegetation with the complementary of red, that you remember is the cyan. Then we will represent in yellow for the complementary of blue, and the magenta for the complementary of green. So let's start with the red one, these first windows here, you see. So we are using the cyan. Let's open the data manager. We are using we want to represent the vegetation in cyan. Let's open the band selection. In the scheme that we have, we mentioned earlier, we need to load in the other 2 principal colors the bands that is reflecting most for the vegetation in the red channel, the bands that is reflecting less. So we are associating to the red channel the red band, and in the green and blue channel we are associating the near infrared, the same band. Okay, so in RGB we will have red, near infrared, near infrared. Okay, all right. In this case we are associating to 2 channels the same bands. So we are load data, and you see that using that now all the vegetation is in cyan. You see, here is in cyan, before was in red. You see, with this kind of synthesis exploding the association, you see red channel red, green and blue near infrared, while before we had another situation. So having more than one view in the same view, we can activate, for example, that things here. So you see, I can flicker these things in order to check it. So let's continue flickering this first window. All right, let's go to the second views. So select that. You see, we have the cyan frame of the selected window. So you see, this is the association in order to represent in blue the vegetation. Now we want to represent the vegetation in yellow. So we need to do the exact same things that we performed before, and associating to the red and green the near infrared, and to the blue bands, for example, a band that is reflecting less. So for example, to the red channel, we are associating to the red channel the near infrared band, and associating to the blue channel another band. So we are associating the near infrared to the red, again the near infrared to the green, and we are associating the red band to the blue channel. Load data, and you see that we have the yellow color. I'm closing the windows, and you see I'm exploding here. This is the association. All right. Okay, so you see here, I can use, for example, another animation. For example, I can use the blend here, the blend option, and you see that is passing from blue to yellow. All right. So it's passing from blue, the principal, to yellow, that is complementary. So now I'm selecting the third windows, you see here. All right. So I need to represent, say, in magenta the vegetation in this case. So open the data manager. All right, let's open the band selection. In order to have magenta, I need to associate to the red and blue channel the near infrared bands, and to the green channel, I need to associate, for example, the red band. So I'm associating the near infrared, the red band, and in the blue again, the near infrared. I'm loading the data, and you see that the results is the magenta color. Okay, we are activating the third option of animation. This is the swipe, and you see here, you see that now in every single Windows I have all the different animation with all the different colors. And you see, we manage and we succeed in managing the principal and complementary colors. So since this effort is already done, and you see that the results are quite pretty to see, in the terms that we have activated the different animation options, let's save these views. So we are going to the main menus, save here, and you see we can, for example, color management here. This is in Italian, but you can, of course, assign whatever name you want with the same extension that is JSON. So let's save that. If you have already this file, you can overlap that. And now we freeze the situation because it's saved. Of course, we are not saving the data. We are saving only the arrangements of the layout. So in order to, before ending these labs, we are taking into consideration some other processing. So in order to start with this operation, we can use all the different functions. So let's close everything. In this case, we have already saved that. So we are going here, File, Close all files. Of course, you have a warning, so we are closing everything. So you see, it's close everything. And when all the views are empty, with the right button of the mouse, we can remove the different views. You see, I'm removing all the different views apart from one, the first one. Okay. So at this point, we go to the data manager. You see that in the data manager, I don't have anything more. So we need to reopen. So we can redo the same operation. So from File, we are going to open as, you see here, open optical sensors, Landsat, GeoTIFF with metadata. Press OK, all right. So we are using again the same Landsat 8 set of data. Okay, let's reopen that. And of course, it's centered in the true color image. I'm zooming out. All right. So I'm pan that in order to have the data centered in the windows. So at this point, we can use a new function. But in order to use this function, we need to do another things. We need to introduce what we mentioned in the theoretical part that and you can review that is concerning the transformation that we can perform on our data for example, what we call the density slicing. So to take the histogram of the image, the distribution histogram, and to associate for one single spectral bands, to associate color to particular intervals of values of the same bands. So this operation can be applied to a single bands and associating these digital intervals, the interval of numbers ranging from 0 to 255, we are associating to these intervals of numbers a particular color in order to visualize a single bands in colors, for example. How we can do this operation? That this operation can be done simply by going to the layer manager, clicking with the right button of the mouse. You see here, pop-up menu, and you see we can select here new raster color slice. Here you have. So in this new raster color slice, you see that this operation of density slice can be done with one only single bands. You need to decide what band you can use. For example, you can use, for example, here, the near infrared. For example, in which using these bands, we know that, for example, in these bands, we have two regularities that, for example, that the vegetation, if we are in an active phenological state, in the near infrared is reflecting a lot. And in the same bands, water is a very strong absorber of electromagnetic energy coming from the sun. And so, in this case, you can differentiate from vegetation and water, for example. And so, the water is a very strong reflective surface, the vegetation, and the water is a very low reflectance surface. So, for example, here, you see, just habilitating these bands, you see that in these windows, that is very interesting, because it's extremely didactic, these windows. Look at these windows. You see here, you have all these different values. You see the minimum and the maximum value of the digital number from 5 to 2055. So the radiometric resolution of the Landsat 8 is different from the Landsat 7, is larger than 8 bits. So at intervals of digital number is associated these colors, you see? And this is the table of conversion. So if a digital number read from the data is in this interval, will be represented in the views with these particular colors. You see here we have the histogram of the distribution. We are going in the details of this histogram next lab, but you see this is a representation in which you have the diagram where in the two coordinate axes, you have on the x-axis the digital numbers, and in the y-axis, you have the frequency. So how many cells are represented in that particular digital number, all right? So this is what is vulgarly and technically called histogram. That is nothing more than the function that represent how many cells, the frequency of the cells for every single radiometric values. So you see that, the function that is done in this way is, you see the black function is very similar to a normal distribution. So that means that the digital numbers are not equally distributed, but are distributed in a stochastic way, because it's represented in a function that is quite similar to a normal distribution, to a Gaussian distribution. So we have very few cells with very high values, and we have very few cells with lower values. And you see, in this case, this is the density slicing, because I mean, you see, we can have vertical slices of the histogram that is represented in different colors with these slices that are color slices. All right, so it's very easy to understand this density slicing, the way in which we can represent a panchromatic image in colors. And you see that the image is very different, because you see, when we are representing that in colors, it's more contrasted, of course. You see, there is a very low contrasted images, the original one in panchromatic, in gray tones. But if you are presenting that, the visibility in color, so you see that is very different, because for our eyes, we can better understand the difference in reflectance by using the colors. So let's begin with the exercise. So let's try to take out the visibility of parts of these things here. So you see here, I'm taking out the visibility of the higher values, and you see that when I'm taking out this visibility, the image is refreshed. So you see, I'm taking the higher values, and you see here now I have black values, and you see now is appearing the image that I have in the background, because I'm getting out values. There are not a different class in black, but is appearing what is back in the pile of the image in the same views. All right. So I'm taking out everything, you see, and whatever is in gray tones is coming from the background image. And you see that now I have only the lower values of these bands. You see, leaving only the very low value, you see that what is coming out is the fact that, I mean, I have all the sea and all the part of the mountains that are appearing. And you see that you can see also the rivers. You see? So considering that this is Torino, you see this is the Po River, that is in this color that we have automatically associated to lower value of the infrared bands. And you see that doing this very simple things here, you see that the river is very well delineated. And you see that you can immediately understand that in this way, simply by coloring the digital intervals in a different way, we are extracting information from the data, because, for example, it's very clear that in this case we are extracting most part of the water of the image. So it's this operation is an operation that is exclusively done in visualization. We are not saving anything, but you see, whatever is colored in this operation is water. So now we are extracting features, we are extracting surfaces, and we are coloring these surfaces in a particular color. All right. So this is very interesting to perform this operation. So we are just habilitating only in the first class. So getting out the visibility of the second. You see that having only the first class, you see that we have really only the water. You see that if I'm zooming in and I'm going again to the Genoa port, you see what is really unbelievable is that I've extracted the water in a very efficient way. For example, whatever is not water is not extracted, is not colored in this violet, for example. And you see, if we are going in Torino and we are checking the different characteristics, you see this is Torino, I'm zooming in, and you see this is the river, you see, and the river is very well extracted. there are also some colors that, of course, is not water. For example, here we have something that is very regular, and this seems to be water, but they are water because these are rice fields that are in the eastern part of this image, and we will have a multi-temporal exercise based on these things here. And you see here, this is April of 2020. So the rice fields are flooded because the rice is growing. And you see here is very apparent the fact that we have water in this area. So, so you see that simply by associating these colors to the digital interval, we have the possibility, for example, to extract all the water of the image. This is quite impressive, right? So, and you can do that in a very precise way. Having said that these things here, this is a sort of pre-classification based on a single bands. And using these colors, we can also understand better how a single spectral band is reflecting the energy. So in these views is a way in which we can, for example, classify water. You see, it's quite obvious that we have some errors. For example, here, you see, this is not water. These are simply the shadows of the clouds over the ground. But I mean, they are strong absorber, and so they are mixing in this way with the water. For example, here we are in the Po, south of Torino, and these are quarries for the extraction of sands that are typical of the southern part of Torino, that of course are flooded, are small lake. And so that's for sure is water. And you see that we have also here, that is quite typical from who is living in Torino. These are the Avigliana lakes, the two lakes that you see that have been extracted from the image, from this band 4, that is the near infrared band. All right, it's quite obvious that if I'm right-clicking here over the slides, you see I can edit the colors. So we are getting back to these windows and can also edit the colors. For example, here, if I don't like these colors of the first interval and I want to change, I'm right-clicking, I select the blue here, for example, you see, right-clicking, and I'm telling, okay, I'm doing the same things as before, so I'm getting out the visibility of the different layers. It's quite boring, but I mean, do that just for this time. So I'm getting out the visibility of everything. And you see that right now, all the water is blue. That is typically in mapping the color of the waters. You see, it's better, much better than violet than before. You see? On the contrary, in this image, water is represented in very high values. In very high values, and this is the, you see that if we are getting this visibility, there are very few values that are represented in that colors. That means that there are very few cells that have a very high radiometric values because we are in the toe of the distribution. And you see, for example, here we have snow, you see, that is for sure a snow that is on the alpine part, just on the border of France. And you see that, I mean, there are cells, but I mean, they are not there. So I mean, right click on these things here. I can select the band number 15. I select all these different bands here, you see, and I'm going here to the X, and I'm just deleting this class. You see, I'm getting out these things here. And you see all these active values on the toes are till 25,000. So for example, if I'm getting all these green values and selecting these values and eliminating all these things, you see that all the values are concentrated in this part of the images. You see, in the histogram, you see in the function. All right, so the major part of the values of the images is there. So I remind to you that is the infrared band, the near infrared band. That means that the maximum value is represented by vegetation. Okay, so I mean, vegetation is a very good reflector in the near infrared, and this is what is represented here, you see. So just close to the peak of the distribution, I will have the vegetation is probable. So in the class 3 and 4, I should have most part of the vegetation, because you see the most part of this image is represented by vegetation. So let's take the class 3. I right click with that and I change in the colors in green. You see? Class 4, same colors, green. And you see that if I'm moving these windows here, you see that the image is mostly green. Okay, so I'm going to explore the image. And you see that I'm doing a very interesting operation, that from this image, I'm extracting a couple of classes. The blue one, that is the water, and the green one, that is the vegetation. You see what is happening in Torino? Let's represent in Torino. Of course, in Torino, we don't have this water. So, for example, buildings are not reflecting in the near infrared, are very strong absorber. So I'm quite sure that is represented by this class here. You see here is reflecting, is absorbing, but not absorbing in the near infrared so much as the water. So you see, and I'm quite sure that all these values here in cyan, in blue, in light blue, are areas that where we have still vegetation. You see here. So while whatever is black here is urban areas, villages, small cities, while the blue parts, you see, for example, these are urban areas. And so just working with the different classes, so you see here, we can have a sort of classification. So in blue, you have the water, and for example, also the river. You see, we have the green classes that are the vegetation, and we have extracted also the black class. Then the black class is related to urban areas. And then we have also here in the mountains, you see some black parts. And what are these black parts? Basically are areas in shadows where they are not directly exposed to the solar radiation. And the light is not striking over the surface, so that appears to be blackish. So you see that using the density slicing option, we have a sort of real-time pre-classification where we can extract a very useful information. So you can understand that the density slicing is a very useful function. We have also to take into account that there are limitations, for example, for the urban centers and for the shadows. But you see that I can edit these values. For example, I can edit the values of the digital number, for example, from 0 to 8,000, for example, here. I can just press OK. And you see that, for example, all the background of the image that is equal to 0 is represented in the same color. All right. So in order to eliminate the background that is actually not a part of the image, okay, I'm changing from one and not taking into consideration the zero, and you see that not considering the zero, I don't have the background anymore because the background is represented by the zero value. All right, so it appears to be in a transparent way. All right, so this is a very important option, the density slicing. There are also other options. You see here. I mean, I want just to show you. I'm going to the slice, right button. Okay. You see here. So I'm sorry. So raster on the raster color slice, right clicking, I can remove the color slice. You see here. So I'm in the original situation. Right click, new raster color slice. So there are also other possibilities. So let's explore very quickly the other possibilities. So I mean, if I'm exploding these things here, so this is the visible, you remember? So let's open the layer manager. For example, if I'm using the panchromatic, on the same view, so I'm loading the data, so I have a stack of two different representations, the true color and the panchromatic image. And I'm going to the port of Genoa here, or the airport, using the panchromatic that is a higher geometric resolution. Right clicking, I can use the last option that I have in colors, so that is particularly useful. So in the pop-up menu, you see I can change the color table. So I can use, for example, the grayscale, but I can also use other representation. This is the classical representation in grayscale. If I use the blue-white, you see here, I'm representing the same values, but using blue tones. So brighter are the blue, more reflective is in this band, this representation. So again, right clicking, if I'm using, for example, change color table, red temperature, you see here that more bright is the red, more reflective is that surface. I can use also, for example, rainbow, and I can use different colors. Hmm, So if I reactivate the data manager from here, and I'm using, for example, the thermal infrared, all right, and I can load that in a new view, and I load that in a grayscale, of course. I don't have any other possibility. You see, this is the view in rainbow, all right. This is the activation. I'm going to the view and I'm link the two views, all right, in order to have also on the thermal infrared the same views. One is 15 meters and this one is 60 meters. This is why is the focus, because the geometric resolution is lower than the previous one. So I'm zooming out in order to center the airport, you see. Now I am activating the second views. I can use a right clicking, for example, here, the change color, the red temperature that is really makes sense with this band because the thermal infrared as the thermal stays for is a sort of representation of the different temperatures. So you see that in this scale, what is brighter is warmer than what is represented in darker red. And you see, that is a way to represent in colors, in predefined scale of colors, our single spectral bands. So you see, for example, here, these buildings are warmer than the texture that we have around. So if we are going to the previous one, we are changing the colors, and we are here more. You see, we can use all these different scales. You see, we have a bunch of different scales here. So for example, I'm getting this one, for example, from blue to red. And you see, this is another possible representation. And this is just to make them aware that if we need, we can also use other color scales. They are basically, I don't know if they are very useful or not, but I mean, this is a way just to represent single bands in colors. So, very good. Having said that, we have completed this lab. So we are closing the software without saving anything. So we are going here, File, Exit. So we will see again for the fourth labs. And goodbye to everybody, and never give up. Bye-bye.